Okay, you had to, I want to sketch with these things. A sketch is what's really helpful. A sketch is going to put this in perspective for you. You're going to see if this is where your mean is, everything's falling over here between 200 and here. It's less than 50%. You can see that it's already less than 50%. For each one of those, you're going to find your z-score. You're going to take your areas and subtract them. If you use the calculator step, there's your lower limit, your upper limit, your mean, your standard deviation. I still want the sketch, okay? And if you use the calculator, I need the calculator step. Because what happens is if you use the wrong one, you get the wrong answer, I don't know that, and you don't get any credit for it. That's the bad part about using the calculator. Okay. This one too, it's an in-between also. Here's your mean. You're looking at this end of it. That's going to be less than 50% too. Yes?
What happens if you're like 1,000
The rounding in your calculator is different from the area in your table.
I used the table for the first one, I got 30.
Yeah, that's fine. Yeah, the rounding is a little different. Your calculator doesn't round to the 4 decimals. It has its own algorithm. It doesn't really have a rounding scheme. So the calculator actually is more exact than your table. Yeah, I expect it to be a little bit different. That's why you show me the calculator and show me the other one. I expect it to be slightly different. It's not a major hit, just a little. Again, you're finding z-scores. You're finding your areas. Whenever you subtract your area has to be positive. Your area cannot be negative. So make sure you always subtract the larger minus the smaller. The normal CDF, if for anything else, works great on the in-betweens. This in-between works really nice for this one because there's your lower limit, there's your upper limit, your mean, your standard deviation. It kind of makes sense. Just make sure you don't do the PDF, that you do the CDF. That's what accumulates your area. Okay, number 11. Still a chart, right? We're still in the chart. We get a chart here, and they want to know between 167 and 174. A lot of this is repetition, and I realize that. But the thing is, once you establish a pattern in your work, it gets a lot easier. Your sketch, your probability statement, your z-scores, your areas, it's kind of repetitious, but it's going to help you develop something here. So for each x, you find your z-score, find your areas, and subtract your areas. You're looking at a small area. Stop me if you have any questions. Number 16 we did in class. 20 was very similar to 16, but it wasn't symmetric like 16 was. 16 was exactly symmetrical. You had the same z-score, positive and negative. This one didn't. So you're less than 17, you're here at this z-score. You're 22, you're here at this z-score. Find your area for the more than and the in-between, guys. You can take your areas and subtract them. You've got this one and you've got that one. They really should have put this last so that you do that one, you do this one, and then you do the in-between. It's kind of real small, I realize. Better? Questions? No? Everybody can do this. Yeah? Make sure I get sketches on these. Okay, here's 22. 22 gives us a little scenario here. These are your SAT scores. Your standard deviation works fantastic with your SAT scores. Your SAT scores are, everyone takes your SATs. So you should get a normal curve from your SATs. If I give a test in here, my test results normally don't come out like a normal curve because you're taking a higher level course. Most of your grades are a little on the higher side. SATs, everyone takes an SAT. whether you're like getting the lowest or the highest, most of the scores still fall between 1 and plus or minus 1 standard deviation when you do these. So they really do make a normal curve for your SATs. So that's where usually you see any of your ACTs, SATs, usually they like to use the standard deviations with them. You want to know what's the probability that you randomly select someone that was less than 500? Look at 500 is to the left of your mean. Your z-score is going to be negative. You look up the area to the left. It's easier to interpret it as a percent. The probability that the person you pick has a score less than 500 is about 43%. 43% chance that that person had less than 500. More than 600, look at the difference in the probabilities. You only have a 24% here. That's a higher score. You're above the mean. Now, when they give you an amount and they ask you for if 1,500 kids took this test, how many do I expect to be greater than 600? Well, you already figured out your probability of this. You said about 24.2% of the 1,500 should make that score. So all you have to do is multiply that. Just multiply it by 1,500 and round down. Because rounding up means you had that extra person. Round down on these. Is everybody okay with this? And the 1 minus thing? Everybody can do the area further to the right, 1 minus? 24. 24 was about cholesterol. What percent of women have a total cholesterol less than 239? So we look at our chart, less than 239, it's in the positives. It's going to be more than 50%. And if we come out with more than 50%, we know we're on track. How many have greater than 200? Greater than 200, it's in the negatives, but it's to the right, and that's going to give us more than 50%. So if you came out with 29.81, and you look at your graph, you say, that's got to be larger than 50%. I forgot to subtract from 1. So there's what's going to make it larger than 50%. Of the 200, I said round up, don't round up. They say round up, I say round down. So times it by your 200, and you'll get your score. How many do you expect out of the next 200 people that you test to be greater than 200? You were very talkative earlier. Is he asking any questions? Okay, 26. This is your monkey one. Did we do this one? We did 16. But we did this the other day, right? Did we do the rhesus monkey one? No. They also had one? Okay, here's another one. Your mean is 15. Your standard deviation is 3. Greater than 20. Look, it's a smaller area greater than 20. Less than 12. Yep, that's a smaller area too. If you had 50 people, you're going to round down. 28. The last one. It's your utility bills. You have a mean of 100, a standard deviation of 12. What percent are larger than 125? So we take a look at where your 125 falls. We want to the right, greater than. We find your percent, less than 90. If you had 300 people's bills you were looking at, what is the probability that they're less than 90? Is 60.99%. If I take 60.99%. Oops, nope, I didn't do a percent. There it is. 20.33%. If I take that of 300, I'll figure out how many people make that bill. Questions? Okay? You see it? Okay.